You're sitting in a meeting. Nothing is wrong. No one is angry. No one is in danger. But your heart is beating faster than it should. Your palms are slightly damp, and some part of you feels like you need to escape. You don't know why. And that's exactly the point. Your brain doesn't know you're in a meeting. It thinks you're being hunted, not metaphorically, not as a figure of speech. The exact same neural circuitry that kept your ancestors alive on the open savanna is firing right now, in a temperature-controlled room, under fluorescent lights, in the middle of a conversation about quarterly reports. The hardware hasn't changed, only the world around it has. This is one of the strangest stories in human history. It's the story of a brain built for a world that no longer exists, running inside a body that has to survive a world it was never designed for. And once you understand it, you will never look at your own anxiety the same way again. Here's where the story begins. About 300,000 years ago, your ancestors lived in small nomadic groups on the African savanna. They hunted, they gathered, they slept in the open. And every single day, there was a genuine possibility that something was going to kill them. Predators, rival groups, disease, starvation. The environment was not safe. It was not predictable. It was not forgiving. The brain that survived all of that had to be built a very specific way. It had to be fast. It had to be paranoid. It had to treat every ambiguous signal as a potential threat, because in that environment, assuming something was harmless when it wasn't would get you killed. Assuming something was dangerous when it wasn't would just cost you a few seconds of panic. The math was simple. Paranoia was free. Complacency was lethal. Neuroscientist Joseph Ledoux spent decades mapping this system. What he found was an ancient alarm structure buried deep in the center of your brain called the amygdala. Two small almond-shaped clusters of neurons, one on each side, constantly scanning your environment for anything that even remotely resembles a threat. And here's the part that changes everything. The amygdala does not wait for your conscious brain to process a situation before it reacts. It fires first. It floods your body with stress hormones before you have fully seen what you're looking at. Ledoux called this the low road. A signal enters your eye. Before it ever reaches the visual cortex where you would consciously process an image, a shortcut fires straight to the amygdala. Your heart rate spikes. Your muscles tense. Your breathing shallows. And only then, a fraction of a second later, your conscious brain catches up and says, "Oh, it's just a shadow on the wall." But by then, the alarm has already gone off. The stress hormones are already in your blood, and your body now has to process an emergency that never actually existed. This happens to you dozens of times every single day. You probably don't even notice most of them. A car horn in traffic, someone calling your name in a tone you don't immediately recognize, a sudden notification on your phone late at night, a stranger looking at you a half second too long. Each one of these triggers the same ancient sequence. Alarm first, assessment second. The order never changes. But here's what makes this so strange. The brain doesn't just respond to physical threats, it responds to social ones with exactly the same intensity. This is a discovery that upended decades of thinking in evolutionary psychology. Researcher Naomi Eisenberger ran a now-famous experiment at UCLA in 2003. She put participants in a brain scanner and had them play a simple ball-tossing game with two other players, who were actually computer programs. Partway through the game, the other players stopped throwing the ball to the participant. They were excluded, left out. And the brain regions that lit up? Exactly the same ones that activate when you feel physical pain. The anterior cingulate cortex. The anterior insula. Your brain registered social rejection as an injury, because for your ancestors, it was. Being excluded from the group was not a minor social discomfort. It was a death sentence. Alone on the savanna, without your group, you were prey. The brain learned to treat belonging like oxygen and social threat like a blade. So now your nervous system is running threat detection software that makes no distinction between a lion in the grass and a comment on your social media post, between a rival tribe and a passive-aggressive email from a coworker, between being left to die in the wilderness and being left on red. The threat circuits are the same. The response is the same. The intensity is the same. And this explains so much. It explains why public speaking triggers the same fear response as a physical emergency. Standing in front of a crowd, being evaluated, risk of failure, and humiliation. Your brain maps this directly onto ancient social exclusion threat, which maps directly onto physical danger. It's not irrational. It's the precise execution of ancient survival code. It explains why financial anxiety keeps you awake at 3 in the morning. Your conscious brain knows that a difficult financial period is not the same as starvation, but the circuits underneath don't make that distinction. Scarcity is scarcity. Threat is threat. It explains why you replay arguments for days. The amygdala is running a loop, scanning the memory for information it might have missed, because resolving a social conflict was once critical to your survival, and the brain doesn't want to drop it until it's satisfied the threat has passed. Psychologist Martin Seligman introduced a concept called preparedness theory, the idea that humans are not equally afraid of all things. We are biologically pre-wired to acquire certain fears faster than others. Spiders, snakes, heights, darkness, the faces of angry strangers. All of these fears can be learned in a single traumatic exposure and are extremely difficult to unlearn. Meanwhile, modern threats that should logically terrify us, like cars or electrical outlets, don't trigger the same visceral, persistent fear. Because our ancestors never evolved fear responses for those things. There was no selection pressure for it. Your brain is running threat software written hundreds of thousands of years ago. It was never updated for cars. It never needed to be updated for cars. Cars have only existed for about 150 years. Evolution doesn't work on that timescale. But spiders have been dangerous to humans for millions of years. So that fear is hardwired deep and fast. And now you live in a world where spiders are almost never lethal. But your amygdala hasn't gotten the memo. It is still operating on ancient patch notes. This mismatch between your ancient brain and your modern world has a name. Evolutionary biologist and physician Randolph Nesse called it the smoke detector principle. A smoke detector that only goes off when there is an actual fire is a terrible smoke detector. A good smoke detector goes off at the first hint of smoke, even if 9 out of 10 alarms turn out to be a false alarm. The cost of a false alarm is low. The cost of missing the fire is catastrophic. Your brain is a smoke detector. It is calibrated for a world where the cost of ignoring a threat was death. So it fires constantly. It fires at ambiguity. It fires at uncertainty. It fires at anything that even statistically resembles a pattern it once associated with danger. And you live in a world saturated with artificial smoke. 24-hour news cycles feeding you stories of threat, catastrophe, and social danger from every corner of the planet. Social media platforms algorithmically optimize to surface content that provokes the highest emotional response, which turns out to be outrage and fear. Emails that demand attention at midnight. Notifications designed by engineers who study exactly what triggers your ancient alert system and how to trigger it more efficiently. Your brain is being ambushed by an environment that has learned how to imitate predators. And here's the counterintuitive part. The smartest, most aware people are often the most affected. Because a larger, more connected prefrontal cortex, the part of the brain responsible for complex reasoning and empathy and long-term planning, doesn't override the amygdala. It amplifies it. Your ability to imagine future consequences means you can project threat further into the future than any animal ever could. You don't just fear the lion in front of you. You fear what might happen next year, next decade, at the end of your life. You are the only animal on Earth that lies awake at night worrying about things that don't exist yet. But you are also the only animal on Earth that can look at its own circuitry and understand what it's doing. That's the other side of this story. The awareness itself is ancient, but the ability to observe the alarm system from the outside, to name it, to understand its origins, to recognize a false alarm for what it is, that's new. Neuroscientist Lisa Feldman Barrett has spent years showing that emotions are not fixed reflexes. They are constructions. Your brain is constantly predicting what will happen next and generating an emotion as a guide for action, which means the story it tells about your threat signals is not fixed. The meaning of a racing heart can be rewritten. Not easily, not instantly, but it can be. When you feel that tightening in your chest before a presentation, your brain is running a prediction model built on every social threat your ancestors ever faced. It is doing its job exactly right, for the wrong world. Knowing that doesn't make the alarm stop, but it changes what you do with it. You are carrying 300,000 years of survival wisdom inside a world that is less than 200 years old. Your brain was not built for this. It was built for something far older, far darker, and far more dangerous. And it is doing its absolute best with the information it has. The next time your chest tightens in a room where nothing is wrong, that's not weakness. That's your ancestors keeping you alive, long after the predators are gone.